Hey guys, welcome back. This video is going to cover problems 11, 12, and 13 on the exam 3 review. So these are problems that might be related to sampling distribution items. So hopefully this will help out with that. Uh, we're going to be taking a look at some problems. Be aware of problems where you might not be able to do anything, all right? So remember, for the sampling distribution to work, you need to have a sample size above 30, or the original population must be normal. All right, so if you don't have that, you can't calculate the probability that they're asking for in the problem. That's the biggest catch, or the biggest gotcha that might happen on the test. Right, so you got to make sure that you can establish normality. Right, sample size greater than 30, or the original population was normal. If you can't get either one of those two things, you can't do the problem. All right, I'll demonstrate that right off the bat here. We have a national study that was conducted, and it found that the mean weight of sumo wrestlers was 326 pounds with a standard deviation of 27 pounds. If you don't know what a sumo wrestler is, they're wrestlers from Japan, and they specialize in getting very, very big, and then they try and push each other out of a ring. So sumo wrestlers are famous for being very large people, right? So you can see the mean weight of a sumo wrestler is 326 pounds. That's very large, right? So, anyways, the distribution of the sumo wrestlers was found to be skewed left. So the population was something that was skewed to the left. So if we are going to do anything with a probability on this, we're going to have to take a sampling distribution that takes samples of size 30 or more, right? So when I look at part A, it says find the probability that one, right, randomly selected sumo wrestler has a weight greater than 400, right? We can't do anything with that. I can't do it with just one, right? Because the original population was skewed to the left. I can't use the normal distribution on something like that. So I always mark these as an IDK CDF, IDK for I don't know, and you'll notice that on my answer key that I provided for you. So if you see something like this, IDK CDF, it's just a joke. It means that you can't do it. All right, and then you would explain why, right? So the sample size that they are taking is less than 30, and the population is skewed left. Oops. Okay, so that's how I would answer that for full credit. All right, let's take a look at the next one. It says find the probability that a sample of 35 randomly selected sumo wrestlers has a mean weight of greater than 400 pounds. All right, so this time we're taking 35 sumo wrestlers at a time. We're going to find their mean. I want to know, what is the probability that the mean of those 35 sumo wrestlers is greater than 400? Well, that is a sampling distribution, and this is one that we can do because when the sampling distribution starts to take more than 30 at a time, it should be normalized. So if I'm drawing a picture of that sampling distribution, it's going to look like a normal curve. And remember that the center is going to be at 326, right? So if I'm drawing in the center here, 326 would be located right here in our distribution. We want to know what's the probability that the mean of these 35 sumo wrestlers is above 400. So 400 is going to be over here. Okay, so there's my 400, and we want to be greater. So we're going to shade everything to the right of 400. So we're looking for the area in that tail right there. So to get that, we're going to do a normal CDF. Okay. And we're going to say the left bound is 400. The upper bound is 1E99. And our mean, right, the center is going to be at 326. And then we have to be careful because in the problem it said our standard deviation was 27 pounds, but we're working with a sampling distribution, so we have to do a correction for the sample size. So I have to do 27 divided by the square root of 35. Okay. So that is what we're going to put into the calculator. So I'm going to grab my calculator, move that over here. Let's go do a normal CDF real quick. You probably don't need to see this. You probably know how to do this already. But just in case you want to see it one more time, this is it. Okay, so we've got 400, 100, 400, and then 1E99. And then we're going to have a mean of 326 and a standard deviation of 27 divided by the square root of 35. You can literally just type that directly in. You don't have to go and get the decimal or anything. Okay. And then hit paste, enter, and there's our probability. So this is a very small probability, 2.1 e negative 59. I would accept 0 plus. All right, let's do it again. This time they want to find the probability that a sample of 40 randomly selected sumo wrestlers has a mean weight between 315 and 350. All right, so again, I would draw my normal distribution. Remember, I used to require you to draw that normal distribution. Anytime you use a normal CDF, you should be drawing this normal curve and drawing out the shaded area that you're doing. I obviously can't make you do that on MyOpenMath, but it's a good habit. It helps you visualize what you need to do with your calculator. All right, bring it over here. I'm going to put the center in 315, and we want the probability that it has a mean weight between 315 and 350. And that should not be 350, that should be 326. Let's see what we get here. So 326, and 315 would end up over here, and 350 would be somewhere over here. And we want that area in between. Right? So we want all this. There we go. So I'm going to do a normal CDF. We're going to do 315 as our left bound, 350 as our right bound. The mean is still 326, but our standard deviation has changed again to 27 over the square root of 40. And let's see what happens here. So I'm going to go to my calculator. I'm going to do the same command, normal CDF. And we've got 315, 350, 326, and then I'm just going to go change this thing in the square root to a 40. And there we go. We got 0.995. So 0.995. And make sure you pay attention to MyOpenMath for the rounding instructions. All right, if you don't see it and you type in an answer and it's marking it wrong and you're absolutely sure you did it right, send me an email and I'll check and see if it's a rounding issue. All right. All right, here we go. So lifespan of a species of a rat. So we're moving on from the sumo wrestlers here. So we got the lifespan of a species of a rat is approximately normally distributed. So they are telling us right off the bat, the population for the lifespan of a rat is approximately normally distributed. So the population is normal. And it has a mean of 2.8 with a standard deviation of 0.8 years. We want to find the probability of a randomly chosen group of 3 rats. Okay, so 3 rats have a mean lifespan longer than 3.5 years. All right. Now, this is a sampling distribution. It is not greater than 30, but it doesn't matter because the original population is normal. All right. So we can still rely on the sampling distribution to also be normal. I'm going to draw a normal distribution. I'm going to mark its center, which is going to be at 2.8 years. And we want to find the probability of being in between or longer than 3.5. So 3.5 would be over here. And we want longer than, so we want the area to the right. I'm going to set up my normal CDF. We're going to say lower bounds 3.5, upper bounds 1E99, and a mean of 2.8 and a standard deviation of 0.8 divided by the square root of 3. So it's still a sampling distribution. So the variation is going to go down because we're taking 3 at a time rather than 1 at a time. So we still have to take into account that correction. All right, go back to my calculator. Let's do a normal CDF. Go. This time we're going to say 3.5. The upper is going to be 1E99. And we have a mean of 2.8. And we're going to go 0.8 divided by the square root of 3. And paste. There we go. So we got 0.065. There we go. All right. So these problems are pretty easy as long as you catch whether or not you're dealing with a sampling distribution or just a regular normal CDF type thing, you're going to be fine. All right. So let's look at number 13. This is another little bit of a gotcha problem. You have to recognize what you're dealing with here. It says you work for an oyster farm and have noticed that about 8 out of every 100 of the oysters grow a pearl inside of them. If you gather a random sample of 78 oysters, what is the probability that more than 10 of them have a pearl? It's interesting, right? They throw this in there, and it seems like a gotcha. It really is, just to make sure that you didn't forget about binomial distribution functions, because this is binomial because it's a two outcome experiment, right? Either the oyster has a pearl or it does not have a pearl. So that has two outcomes. The probability of having a pearl is going to be the same. It says 8 out of every 100. So probability stays the same from trial to trial. There's a set number of trials. All of the requirements for a binomial distribution are met here. So we're just going to use a binom CDF or a binom PDF to solve this problem. So our important information, right, the proportion or the probability of success here is going to be 0.08, right? It's 8 divided by 100. The probability of failure, or Q, is going to be the complement of that, right? 1 minus 0.08, so we'll get 0.92. And then our sample size, right, the number of trials is 78. Okay, so that's really all of the important information that we need. So we got to think, how are we going to set this up? So we want the probability that 10 or more of them. So you have to kind of think back to the earlier part of the semester. If I were setting up a probability distribution, right, you would have your x and your p of x, right? We made these tables, okay? And you would say, okay, well, what's the probability of getting 0? What's the probability of getting 1? What's the probability of getting 2, 3, right? 4, 5, 6, 7, 8, 9, 10, dot, 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 all the way down to 78 because we did 78 trials. We could get 0 pearls, 1 pearl, 2 pearl, so forth and so on. And you would calculate each of these individual probabilities using a binom PDF. All right, so if you need to review that, go back to your notes on binom PDF stuff and you can remember how to do that. But since we want 10 or more, we essentially want this part of the table from here down. Okay, and our binom CDF function will actually add up everything in our table up to a specified number. Okay, so if I do a binom CDF, I can do a binom CDF up to 10 and then subtract that away from 1, and what I'll be left with is everything greater than 10. All right, so I'm going to be doing a 1 minus binom CDF. And the binom function on the calculator wants to know how many trials you do. That's going to be 78. It wants to know what is the probability of success. That's 0.08. And it wants to know, what do you want to add up to? I want to add all of the different outcomes up to 10. Okay. Let me show that to you on the calculator here. So I'm going to go to my distribution menu. I'm going to go down to where it says binom CDF. Right here. And again, just like I explained, it wants to know the number of trials, so it's 78. Our probability of success was 0.08. And the x value is essentially what are you adding up to? We're adding up to and including the 10th outcome on that table. All right, so we're going to say 10. I'm going to go ahead and hit paste. And remember, we wanted to do a 1 minus, but we'll do that in just a second. I'm going to hit enter. So this is the probability of 10 or less pearls, right, which is about 95%. And then to get everything that is more than 10, we would do a 1 minus that result, the complement of it. Just like that. So we're going to get 0.046. Okay. And one more quick thing I just want to note, because we don't really get a chance to see it in this problem, because I didn't make a problem for it, but if we wanted to find the probability that exactly 4 of the oysters had a pearl or exactly 3 of the oysters had a pearl, that's what the CDF function is for. So when you go to your distribution menu, there's the PDF and the CDF for the binom. So when you do the PDF, that's if they want to know exactly 4 or exactly 3 or exactly 15 or however many number of pearls they specify in the problem. When they do something that is greater than or less than, that's when you're going to be doing the CDF function. Okay, because the CDF function is cumulative. It'll add up the probabilities that you need for you. All right. So last thing here is I would just state your probability formula. So we're going to say the probability that we get 10 or more pearls, actually, I'm sorry, strictly more than 10 pearls, is going to be about 4%, right? So 4.6% here. All right, guys, that's it for the exam 3 review. If you have further questions or you need any more clarification on any of these problems, make sure you send me an email and I'd be happy to meet with you before the test. Just let me know. All right, guys, good luck studying. Good luck on your exam, and we'll see you next week for the final.